Hi there and welcome to this video on scatter graphs. What is a scatter graph then? Well, a graph of plotted points that show the relationships between two sets of data is known as a scatter graph. In this example here, each dot represents one person's weight versus their height. They're also known as scatter diagrams or scatter plots. So how do we plot a scatter graph then? Well, here I have information for 8 students, and I got their maths mark and their science mark. I'm going to plot them against one another to see if there's a relationship between them. For student A, they got 56 in maths, which is measured along the horizontal x-axis. It's roughly about here. And they got 62 in their science mark, which is measured against the vertical axis or the y-axis. I'm going to mark with a cross, roughly where that student's marks are. For student B, they got 73 in their maths and 68 in science, which is roughly about here. We can go on to plot all of the students' results in this manner. So from this graph, can you indicate to me which student scored the highest mark on the science test? So I'd be looking for the highest mark measured against the y-axis here, which is mark C. Which student scored the highest mark on the maths test then? Well, I'd be looking for the furthest mark that's represented on the x-axis or the horizontal. That one would be student D. Which of these points indicated on the graph would you say is an outlier? Well done. An outlier is just one that lies furthest away from the general trend of the points. I'd indicate this as point B because I can see the rest of them are in this general region here. Correlation is now one thing that can be measured or seen visually from a scatter graph. Correlation is simply a way of describing the relationship between two variables. It can have a negative correlation, which means as one variable increases, the other decreases. Here you can see that as the marks in the maths test increased, the marks on the art test decreased. You can also have positive correlation, where one variable increases and so does the other. Here you can see that generally the taller the person is, the larger the hand length they've got. And you can also have no correlation, which is indicated when there's no connection between the two variables. Here, the amount a person weighs and the number of hours of TV they watch. You'll have 5 seconds to answer these questions. What type of correlation is shown here? The general trend of these points is moving downwards across the graph. So this is an example of negative correlation. What type of correlation is shown here? Here, no discernible pattern can be ascertained through all of these points. There's no correlation shown here. What type of correlation is shown on this scatter graph? The general trend of these points is moving upwards across the graph. So this is an example of positive correlation. On a scatter graph, we can also draw the line of best fit. Now, a line of best fit just shows the general trend of a set of data. We try to get an even distribution of points on either side of the line. But do know it does not have to go through the origin. In fact, it probably won't. And make sure you use a ruler. But I can see that the general trend is moving upwards across the graph, indicating that as a student's maths mark increases, so does their science mark. It's an example of positive correlation. Which line here would you say is most suitable as a line of best fit? I'd say C here is the best measure of a line of best fit that's drawn. You can see there's roughly an average distribution of points on either side. We might have a slight outlier, but it's definitely showing us the general trend. A and D are just slightly wonky, and B goes in completely the opposite direction. From a scatter graph, we can perform interpolation then. Interpolation helps us to estimate the values of points that we don't necessarily have collected already. We can use this diagram and a line of best fit then to estimate how many scarves would be sold when the temperature is 15 degrees Celsius. If I find 15 degrees then on the y-axis, read across until I hit the line of best fit, and read down, I get the sales of scarves being 40. What about here? Can you use the scatter diagram to estimate how many scarves would be sold when the temperature is 5? Read across from the y-axis at 5 until you hit the line and read down. I'd estimate 90 scarves. What about, can you estimate what temperature it was when the shop sold 30 scarves? So this time read up from the x-axis from 30 and across. I'd estimate that to be about 17 degrees Celsius. What about when they sold 65 scarves? Read up from 65 scarves and read across. That would be 10 degrees Celsius. Try these questions then. You'll have 5 seconds, but if you need longer, press pause and press play when you're ready for the answers. So I want to estimate the weight of a salmon with a length of 85 centimetres. So find 85 centimetres on the x-axis, read up and read across. I'd estimate that to be roughly about 6.8 kilograms, looking at the numbers I'm given as my answers, because I can see it's nearly 7. What about a salmon that weighs 7.5 kilos? How long is that? Well, 7.5 kilos would be here. Reading across and down, I'd estimate that to be 90 centimetres. The graph shows data on ice cream sales and temperature. Why might it not be valid here to use this graph to estimate ice cream sales when the temperature is 10 degrees Celsius? If I was to draw my line of best fit then on this graph, I would see it extends about here. It's really dangerous to extend your line of best fit beyond the data set that you already have. So you can see here that 10 degrees Celsius, I wouldn't hit my line of best fit because the temperature lies outside of our data set. That would be verging on extrapolation then, which we should avoid as it cannot give us reliable and accurate results. Now try all of the complementary resources, either on the RISE programme or Moodle page, to further practice scatter graphs. Thanks for watching.